Good day and welcome to another micrographics webinar. We are an Autodesk partner and reseller. My name is Sean Bauer and I will be presenting this webinar today, 12 December 2024. I am an application engineer and an Autodesk AECO technical consultant with micrographics, and today's topic is sustainability for architects with Autodesk AEC collection. If you find this webinar to be informative, please like this video and subscribe to our channel for future webinars. Let's get into it. On the agenda for today, we'll have an introduction, then optimizing building performance with insights in Revit, sustainable design with generative design in Revit, lifecycle assessment using the Autodesk Construction Cloud and Revit for sustainable architecture, the content catalog for time-saving and collaborative input, then collaborative sustainable design using the AEC collection, then conclusion. Introduction. So the overview of sustainability. Sustainability refers to creating buildings and infrastructure that minimize environmental impact, maximize resource efficiency, and promote the well-being of occupants. It involves designing structures that are energy efficient, reduce carbon footprints, conserve water, and use sustainable materials, all while maintaining a high level of functionality and comfort. The goal is to create environments that meet today's needs without compromising the ability of future generations to meet theirs. The AEC collection contributes to 40% of the annual total carbon emissions globally. Growing populations need more homes, more buildings, roads, etc. What is sustainability in architecture? Energy efficiency, designing buildings to reduce energy consumption by optimizing natural light, ventilation, and insulation, and integrating renewable energy sources such as solar or wind. Material selection, using eco-friendly, renewable or recycled materials that reduce embodied carbon and waste during construction. Water conservation, implementing systems to capture and reuse water like rainwater harvesting and incorporating low water use fixtures. Indoor environmental quality, ensuring that indoor spaces promote health and comfort through ventilation, non-toxic materials, and maximizing daylight. The life cycle thinking, designing with the entire life cycle of the building in mind, from material sourcing and construction to maintenance, deconstruction, and recycling. What is sustainability in construction? Waste reduction, minimizing construction waste through careful planning, prefabrication, and recycling on-site materials. Efficient construction practices, reducing energy used during construction through efficient logistics, smart planning, and using sustainable technologies. Building longevity and adaptability, designing structures that are durable and can adapt to future needs, reducing the need for demolition and new construction. Site considerations, preserving the natural environment surrounding the construction site by minimizing disruption to ecosystems, conserving soil, and promoting biodiversity. Autodesk software and sustainability. Autodesk provides several tools in its AECO architecture, engineering, construction, and operations collection that promotes sustainability throughout the design and construction process. Revit, Energy Analysis Insight, helps architects optimize energy use during the design process by running simulations for heating, cooling, lighting, and solar gain. Material data within Revit, architects can select materials that reduce environmental impacts, such as low embodied carbon options, and assess them using lifecycle data. The Autodesk Construction Cloud, ACC, Lifecycle Assessment. Integrating with Revit, the ACC allows tracking materials and performing lifecycle assessments, evaluating the environmental impact of construction decisions. Collaborative Sustainability, the cloud-based tools enables architects, engineers, and contractors to collaborate effectively on sustainability goals, ensuring that eco-friendly practices are carried out from design to construction. Generative Design in Revit. This tool lets architects explore thousands of design alternatives based on sustainability goals like reducing energy consumption, optimizing natural light, or minimizing material use, helping architects to select the most sustainable option. BIM 360 and Navisworks, coordination for green construction. These tools ensure that construction teams can coordinate and reduce material waste by detecting clashes and planning more effectively, resulting in fewer errors and a more sustainable construction process. Civil 3D and InfraWorks, sustainable site design. These tools are used to create sustainable infrastructure such as storm water management systems, green spaces, and energy-efficient transportation routes, contributing to more eco-friendly urban development. Additional software and extensions as part of the sustainability for architects. We have Forma, Tandem, Carbon Insights, Insight, Green Building Studio, the Content Catalog, and more. We will delve into more detail during this webinar regarding these additional software applications. In summary, sustainability within architecture and construction is about designing, building, and maintaining structures that minimize environmental harm while improving resource efficiency and occupant health. Autodesk's suite of tools from Revit to the Autodesk Construction Cloud plays a key role in facilitating this process. Through energy analysis, material optimization, life cycle assessment, and collaborative workflows, architects and construction professionals can create sustainable projects that meet modern environmental standards. Optimizing building performance with Insight in Revit. Autodesk Insight is a cloud-based energy analysis service integrated within Revit that empowers architects and engineers to optimize building performance and sustainability. By providing powerful tools for energy modeling, HVAC efficiency assessment, lighting analysis, solar studies, and daylighting simulations, Insight enables design professionals to make data-driven decisions for more energy-efficient, environmentally friendly buildings. Key features of Autodesk Insight. Insight provides a user-friendly interface, in-depth simulation capabilities, and the power of cloud computing to deliver comprehensive energy and performance data. The energy modeling and performance analysis. Insight uses a robust energy modeling engine to create detailed simulations of a building's energy consumption. With these tools, architects can assess a project's potential energy use intensity, the EUI, based on various design parameters like orientation, insulation levels, and occupancy patterns. The energy model takes into account external conditions, such as climate data, to provide accurate insight on how the building's location and orientation will impact heating and cooling needs. This allows for optimization of the building's envelope and structural components to reduce energy demand. HVAC analysis. Insight allows users to model different HVAC systems and assess their efficiency under various scenarios. By comparing options, architects and engineers can select systems that minimize energy consumption while maximizing indoor comfort for occupants. The tool considers systems types, efficiencies, and operational schedules, allowing teams to pinpoint an HVAC solution that aligns with both sustainability goals and occupant needs. Lighting and daylighting analysis. Insight provides simulations that allow designers to evaluate lighting levels and daylighting strategies. The tool shows how natural light penetrates the building based on window placement, size, shading devices, and reflectivity of interior space surfaces. With daylighting analysis, architects can adjust the design to maximize natural light, which not only enhances occupant well-being, but also reduces the need for artificial lighting. Designers can also explore how shading elements impact daylight levels, balancing thermal comfort with lighting efficiency. Solar studies. Insight includes tools to analyze solar exposure and shading effects, helping architects optimize the building layout and orientation for solar gain, or shading as needed. By performing solar studies, designers can determine the ideal window placement and shading strategies that help control heat gain in warmer climates and capture solar warmth in cooler areas. This analysis aids in designing facades and shading elements that effectively manage sunlight, improving energy performance and thermal comfort. Cloud-based computation. Insight leverages the power of cloud computing, allowing complex simulations to run quickly without taxing local hardware. This speeds up the iterative design process by enabling rapid testing of design changes, with performance simulations completed and results delivered in real time. With Insight's cloud-based model, architects and engineers can access simulations and results from any location, promoting collaboration and enabling teams to work together on sustainability goals regardless of the location. Energy benchmarking. Insight offers energy benchmarking, allowing designers to compare their project's energy performance against similar buildings in the same climate zone. This comparison provides a clear picture of where the design stands in terms of energy efficiency and helps in setting realistic, data-backed energy targets. The tool highlights areas where the design meets or exceeds benchmarks, as well as areas for improvement, helping architects make targeted adjustments to reach specific performance goals. Customization and flexibility. Users have the flexibility to test various scenarios by adjusting parameters like occupancy, material choices, and insulation types. This adaptability allows designers to customize simulations according to the specific needs and constraints of each project. By tweaking different parameters, architects can identify the most sustainable and cost-effective solutions, minimizing environmental impact while maximizing building performance. So in conclusion, Autodesk Insight is a data-driven approach that provides architects with actionable intelligence, empowering them to make choices that contribute to sustainability and building performance. For example, in designing a mixed-use building, Insight enables the architect to explore different window arrangements and HVAC systems to determine which option best balances the energy efficiency with the occupant's comfort in mind. Transforming sustainable design with Autodesk Insight. By integrating Insight within Revit, Autodesk offers a powerful, comprehensive platform that allows architects and engineers to build sustainability into their design process. Insight's simulations provide a clear roadmap to energy-efficient, high-performance buildings aligning with industry standards like LEED and WELL. Through accurate data, cloud-powered simulations, and actionable insight, Autodesk Insight is a valuable tool for architects committed to reducing energy use, cutting operational costs, and contributing to a more sustainable future. Sustainability design with generative design in Revit. So what is generative design? It's a tool for sustainable architecture. Generative design in Revit leverages algorithms and user-defined goals to automatically generate and evaluate multiple design options, enabling architects to optimize projects for sustainability. By inputting specific parameters such as energy efficiency, material usage, natural ventilation, and more, architects can use generative design to create eco-conscious buildings that align with sustainability goals. How generative design works in Revit? Generative design in Revit uses algorithms to explore a range of design alternatives based on the criteria that was set by the user. These algorithms run simulations that evaluate each alternative, providing the architect with an array of options that meet specified objectives. For example, sustainability-focused goals might include minimizing material waste, reducing material volume, and optimizing structural components to lower embodied carbon. Optimizing the building's orientation, adjusting the building's orientation and facade design to capture or reduce solar heat depending on the climate needs. Enhancing natural ventilation, designing floor plans that promote cross-ventilation, minimizing the need for HVAC systems. With generative design, architects can experiment with thousands of design permutations to identify the best balance between sustainability, cost, and functionality. Sustainability use cases. Material efficiency. Generative design in Revit can help architects optimize the volume and type of materials that are used in a project. For example, algorithms can test configurations that minimize the quantity of concrete, steel, or other high embodied carbon materials while ensuring the structure remains safe and functional. By reducing unnecessary material usage, generative design not only cuts down costs, but also lowers the environmental impact of construction. This can be especially effective in projects targeting low embodied carbon or seeking certifications like LEED, L-E-E-D. Energy optimization. Generative design is highly effective in optimizing energy use through strategies like maximizing daylight penetration and minimizing dependence on artificial lighting. By configuring window placements, orientation, and even internal layouts, architects can use natural light to reduce energy consumption and improve occupant well-being. For natural ventilation, generative design can explore floor plan layouts that promote airflow, reducing the need for mechanical ventilation systems. This is especially beneficial in climates where cooling loads are high, as it reduces energy demands and aligns with passive design principles. Comparison of alternatives. Generative design enables architects to quickly compare various design alternatives, focusing on sustainability metrics such as energy use intensity, material efficiency, and life cycle costs. By visualizing these metrics in a comparison, architects gain insight into the environmental performance of each option before making a final decision. This allows for informed trade-offs between different aspects of sustainability, like choosing between a slightly higher upfront material use in exchange for lower long-term energy cost. Example workflow. Improving energy efficiency in an office building. As an example of how generative design might be used in Revit to enhance the sustainability of an office building. First, setting goals and parameters. The architect's primary goals are to optimize daylighting, reduce energy demand for artificial lighting, and enhance natural ventilation. Key parameters include window placement, building orientation, and floor layout. The architect defines the site climate data, specifying the amount of sunlight, wind patterns, and temperature ranges, as well as an occupancy schedule for energy use calculation. Second, running the generative design. The architect uses generative design to create thousands of configurations Configurations, testing different orientations, window layouts, and structural features. Each iteration is evaluated based on daylight performance, ventilation efficiency, and overall energy demand. The algorithm assigns scores to each option, highlighting the best performing alternatives that align with the initial sustainability goals. Third, analyze the results. The design team reviews the results, noting options with optimal daylighting that reduce artificial lighting needs by up to 40%. One configuration stands out, featuring a facade design that allows for cross ventilation while reducing solar heat gain. This layout minimizes cooling loads, providing a comfortable interior environment and reducing HVAC energy demands. Finally, the selection and implementation. After comparing several top options based on their energy efficiency and material use, the architect selects the design that best aligns with sustainability goals. The chosen design includes optimized window placement and building orientation, which together reduce the building's overall energy consumption by up to 30%. In conclusion, sustainable impact of generative design in Revit. Generative design in Revit provides architects with a powerful tool to achieve sustainable outcomes by optimizing and automating design decisions. Through material efficiency, energy optimization, and real-time comparisons, architects can leverage generative design to create eco-friendly buildings with lower operational and embodied carbon. This approach not only supports a more sustainable future, but also enhances the quality and performance of the built environment, making generative design in Revit an invaluable asset in sustainable architecture. The Lifecycle assessment using Autodesk Construction Cloud and Revit for sustainable architecture. Lifecycle assessment, LCA, is a comprehensive method for evaluating the environmental impact of a building over its entire lifecycle, from raw material extraction, manufacturing, and construction through operations and maintenance to demolition and disposal. LCA provides critical insight into the environmental costs of every stage in a building's life, allowing architects, engineers, and builders to make sustainable choices that reduce the overall carbon footprint and resource consumption of a project. This assessment process has become an integral part of sustainable design and is key for projects aiming to achieve certifications like LEED, WELL, and BREEAM. Integration of Autodesk Construction Cloud and Revit for the Lifecycle assessment. Autodesk's Construction Cloud and Revit combine to offer a streamlined approach for conducting LCAs within the design and construction phases. By providing LCA tools directly within Revit and integrating them with ACC, Autodesk enables architects and engineers to assess and mitigate environmental impacts early in the design process and throughout construction, supporting a lifecycle-focused approach to sustainability. Material choices and embodied carbon. A key component of LCA is selecting materials that minimize environmental harm. Within Revit and ACC, architects can track and select sustainable materials by examining factors like embodied carbon, energy consumption during production, and recyclability. Embodied carbon refers to the total greenhouse gas emissions associated with the production and transport of building materials. By assessing embodied carbon through ACC, architects can compare material choices and prioritize options with lower emissions, such as sustainable sourced wood, recycled steel, or low carbon concrete. Revit models can include data on each material's embodied carbon, allowing for real-time assessment and targeted material choices. Recyclability and resource efficiency. ACC's material tracking feature provides insight into the recyclability of various options, supporting sustainable end-of-life planning. Architects can choose materials that are either fully recyclable or have longer lifespans, aligning with circular economy principles that reduce waste and preserve natural resources. Sustainable construction methods. The ACC platform enables teams to evaluate the sustainability of different construction methods. From prefabrication to modular construction, ACC supports more sustainable construction approaches by helping architects and builders analyze the environmental impact of various techniques. This allows for data-backed decisions to minimize waste, reduce resource use, and shorten construction timelines. Construction waste reduction. By evaluating the environmental impact of construction methods, ACC allows teams to choose techniques that reduce waste. Prefabrication, for example, produces components off-site in a controlled environment, significantly reducing on-site waste and optimizing material use. This approach is often more sustainable than traditional construction methods and can be monitored and tracked through the ACC. Energy and resource efficiency. The platform also helps teams choose energy efficient construction methods by providing data on energy consumption, resource use, and transportation needs for different construction scenarios. ACC's tracking capabilities ensures that chosen construction methods align with both environmental and efficiency goals, supporting reduced emissions and cost saving. End-of-life considerations. Planning for the end of a building's life is essential for a holistic LCA. The LCA tools in Revit and ACC allows architects to incorporate end-of-life scenarios into the design process by evaluating how materials can be repurposed, recycled, or disposed of sustainably. So sustainable demolition and deconstruction. ACC provides data that supports sustainable demolition planning by highlighting materials that can be reclaimed or recycled. For example, materials with lower embodied carbon that are also recyclable, like steel and aluminium, can be more easily reused or repurposed, minimizing landfill waste. Material durability and lifespan. Revit's LCA tools offer insights into the longevity and maintenance needs of materials, enabling architects to choose those with longer lifespans and lower maintenance demands. Durable materials reduce the environmental impact over time, decreasing the need for replacements and reducing lifecycle costs. A case study. Using LCA to select low embodied carbon concrete. In a recent example, a large-scale commercial building project utilized LCA within Revit and ACC to select low embodied carbon concrete alternatives, which had a measurable impact on the project's sustainability. The design team's goal was to reduce the project's overall embodied carbon while maintaining structural integrity. The defining project goals. The team set a target to reduce embodied carbon in structural materials by 25% compared to standard concrete options. This required a close assessment of material alternatives. Comparing material options. Through Revit's LCA tools, the team was able to evaluate different types of concrete mixes, including options with recycled aggregates and fly ash. The environmental data provided by ACC allowed the team to compare each option's embodied carbon, as well as the implications of each material for construction, maintenance, and end of life. Selecting low carbon concrete. After comparing multiple options, the team chose a low carbon concrete mix containing 50% fly ash. This choice reduced the concrete's embodied carbon by 35% compared to traditional Portland cement. The team also documented these findings in ACC, tracking carbon reduction goals and sharing the results with all project stakeholders. The long-term impact. The low-carbon concrete mix not only reduced the environmental impact, but also enhanced the building's appeal to eco-conscious tenants. This example demonstrated how informed material selection, supported by the LCA data, aligns with sustainability goals and adds value to a project. In conclusion, the impact of ACC and Revit on sustainable lifecycle assessment. The Autodesk Construction Cloud and Revit's integration of the lifecycle assessment tools allows architects, engineers, and contractors to evaluate environmental impacts throughout the building's lifecycle. By focusing on sustainable material choices, environmentally conscious construction methods, and end-of-life planning, ACC and Revit equip professionals to make decisions that align with long-term sustainability goals. With the insight provided by LCA, these tools support an industry-wide shift towards net zero buildings, reduced weight, and an overall reduction in the built environment's carbon footprint. The content catalog. So what is the content catalog? It was launched on August 15th, 2024 for the Autodesk Construction Cloud accounts stored in the US server. For the Europe and Australian servers, it was launched on September 16th, 2024. It is available for free for all Docs users, Autodesk Construction Cloud Docs users, and that is the website to get to the content catalog. So how can you ensure data consistency across projects and stakeholders? The Autodesk Content Catalog is a cloud-based content management system, so BIM management. The challenge of model data and BIM assets and the consistency of them. One of the pain points in BIM workflow is that the same piece of content may have been duplicated dozens of times in fragmented locations without a clear workflow or available tools for search, save, and transfer of the digital content from project to project. We have fragmented locations, multiple versions, inconsistent information, lack of knowledge, transferring families, materials, and more from one project to the next, hard to find. In Revit, we build models and families as we progress, and without having a centralized repository, we save our families and materials in multiple projects, different places, and when you are trying to find that specific chair or window or door that you created, you can't seem to find it. With the Autodesk Construction Content Catalog, you can save all your Revit families and materials in one centralized cloud-based platform, which is then readily available for all members of the team from within Revit on the ribbon, where you can add your families, download them directly from the Content Catalog. You will find under the Insert tab, next to Load Family, Load Autodesk Family, Load from Family panel, the Content Catalog. Accessing the correct families which are up to date, and with a simple Insert button, load any family into your project, knowing that it is the latest and up-to-date version of that family, including all windows and doors and more, giving access to multiple users with different levels of permission, from view only to download to upload, and full administrative controls. So how the user interface has been laid out. You have the single source of truth, stores your firm's internal content in the cloud, so you always have access to the latest and most accurate versions. You can also approve or decline uploaded BIM and non-BIM content, ensuring users have access to your healthiest and most relevant digital assets all in one location. You have version control. Create and effectively manage multiple versions of your content. You can have one chair that is available for inserting into a project for Revit 2020, 2021, 2, 3, 4, and 2025. The same door available for all 5 latest versions. You have flexible input. Work confidently with various formats and sources of content, including integrated workflows. Database and content management. Organize your content into customizable collections and sort them by category or by tags. You have a granular search function. Search for your BIM and non-BIM content by any field or parameter, including content parameter. So let's say you loaded up a door. The door can be searched for by typing in door. You can type in glass in the door, the size of the door, the material of the door. All the parameters that you add whilst creating the family can be added as tags inside the content catalog to search for. Additionally, find content you need quickly with the dynamic granular search function, such as the door. Select your door and view your door for additional information. You will see the properties at the bottom of the screen, the panel width, height, louver, all the information. You also have a 3D view where you can turn the entire door and view it in 3D, and you have additional images on the side. There you can add additional tags to this door, and you can add it to more than one collection. Then at the bottom you have your file history and file information. The file history tells you which year versions this door can be placed into. Currently it is set to 2025. And then at the top right you can just select insert and it will place it inside your project in Revit. Okay, collaborative sustainable design using the AEC collection. Autodesk Forma, ACC and Revit, the foundation for data-driven sustainable design. Autodesk Forma and the Autodesk Construction Cloud serve as powerful platforms for sustainable design, facilitating informed data-backed decisions early in the project lifecycle. Autodesk Forma enables urban designers and planners to analyze environmental factors like sunlight, wind, and noise at the neighborhood and city scale. These insights guide more sustainable choices, such as optimizing building orientation for passive solar gain or determining ideal green space placement to enhance the urban cooling. The Autodesk Construction Cloud then connects these early design choices through construction, ensuring sustainable measures are carried through to completion. ACC's collaborative environment allows all stakeholders to access and share sustainable data, reducing duplication and waste. It tracks sustainable materials, facilitates efficient workflows, and enables lifecycle analysis, ensuring each decision is in line with the project's sustainability goals. Forma, formerly known as SpaceMaker, is a cloud-based AI-assisted analytical software for simulations analysis that can enhance your Revit model and the workflow. As a cloud-based AI-assisted analytical software, Autodesk Forma leverages cloud computing and artificial intelligence and machine learning to assist in the analysis of architectural, engineering, and construction designs. Integration with Revit. Revit models can be integrated with Forma. This integration streamlines the workflow for users who are already familiar with Revit. Early stage conceptual design. The focus of Forma is on massing elements for early stage conceptual design, which implies that Forma is designed to assist architects and designers in the initial phases of a project when key decisions about massing and spatial organization are being made. This means less time spent in early stage design. The geolocated site with analytical data readily available, such as the temperature, the wind impact, microclimate, noise analysis, and more, thus saving time and money. The bidirectional sync between Revit and Forma. You can upload your model from Revit to Forma and vice versa to continue working in Revit, and then importing it back in again into Forma to rerun the analysis types to see if the design change you made actually makes a change with regards to the wind, sun, and other types of analyses. You can run, for example, the sun hour analysis to see how the design impacts how the design changes that you made in Revit impacts the sustainability of your project. Here is an example of selecting the month, the day, time of day to do a sun hours analysis. Within a few seconds, you can view the impact the design change that you made will have on the structure. You have your time interval. You can select the time of day. You have a graph on the right here to show you how much direct sun will be on the facades on the ground. You have a scale at the bottom according to how many hours a day there will be sun. This was for a full day, midnight to midnight on November 15th in Cape Town. You have an inspect tool at the top that allows you to pinpoint locations where you can make design changes. For example, there we see not enough sun hours during the day, meaning we will need to have artificial lighting there, versus the outside we will have 8 hours of sun a day on the 15th of November 2024. Revit is central to sustainable design within the AEC collection, allowing architects and engineers to model and assess buildings with sustainability in mind. Analyze in Revit enables performance analysis directly within Revit, offering insight into heating, cooling, and lighting demands. This real-time data allows architects to make immediate adjustments to improve energy efficiency, significantly reducing a building's environmental impact. Load your Forma proposal into Revit for further modeling. Add materials based on your configurations with more control over their physical properties. Use your generative design to give you the best layout and cross ventilation, and then send it back to Forma to analyze again. Autodesk Insight tool provides even deeper energy analysis, running simulations to help architects understand the design's projected energy use intensity and identify areas for improvement. Insight's cloud-based analysis can simulate different scenarios, including the change in insulation, window placement, and material choice, to show how small design adjustments impact overall energy consumption. With Insight, architects can make targeted modifications to create high-performance buildings with reduced carbon footprints, especially valuable in reaching net zero energy goals. The different types of analyses that you can run within Forma: you have area metrics, sun hour analysis, daylight potential, wind analysis, microclimate analysis, noise analysis, solar energy analysis, and then additional analyses by extension. Within Revit, in your Massing and Site tab, you can load your proposal into Revit, and you can have a link between Revit and Forma to rerun your analyses after you've made some design changes. By utilizing these analyses, Forma users can gain valuable insights into various aspects of their designs, facilitating better decision-making and design optimization, resulting in a more sustainable outcome. So, collaborative sustainable design using the AEC collection. In this webinar, I cover the main software solutions provided by AEC's collection with regards to architectural buildings. But there are more software applications and add-ons and extensions that provide additional capabilities within when it comes to sustainability within architecture, engineering, construction, and design, such as the informed design between manufacturing and architecture using Inventor to Revit, or the interoperability tools as an extension, and there are many more that can be added to Revit. Green Building Design Studio plus AI and machine learning. Autodesk Green Building Studio is a cloud-based energy analysis tool that further enhances the sustainable design process by allowing architects to simulate building performance over its entire lifecycle. It calculates energy consumption, carbon emissions, and water usage, providing architects with precise data to make eco-friendly decisions. The Green Building Studio integrates seamlessly with Revit, enabling architects to test multiple design options and assess their environmental impact early in the process. By identifying energy-saving opportunities from the outset, Green Building Studio helps architects design buildings that align with certifications like LEED and BREEAM, supporting both environmental stewardship and client sustainability goals. AI and machine learning driving sustainable innovation. Autodesk integration of AI and machine learning across its platforms has been pivotal in advancing sustainable design. Generative design and other AI-driven features analyze vast data sets, uncovering efficiencies and improvements that lead to resource conservation and reduced environmental impact. Autodesk's AI tools assesses energy performance, simulates structural integrity under various environmental conditions, and recommend sustainable materials, all of which contribute to a more efficient, eco-conscious design process. Machine learning algorithms continually improve, adapting to user input and evolving sustainability standards. For example, AI can identify patterns in energy use across projects, offering architects recommendations for further reducing energy consumption. This dynamic approach ensures that Autodesk's tools remain relevant as sustainability metrics and building codes evolve. Carbon insights. So Revit with the content catalog with the carbon insights together will help quantify environmental impact. Autodesk's carbon insight tools brings powerful carbon footprint assessment into the design process, empowering architects to make more sustainable choices by understanding a design's embodied carbon. Carbon insights integrated with Revit in your ribbon, AEC and other Autodesk platforms, allowing users to assess the carbon impact of materials and construction processes. Through the carbon insights, architects can select materials with lower embodied carbon, make construction processes more efficient, and design buildings that have minimal impact on the environment. This tool is invaluable for projects aiming to achieve net zero or carbon neutral certifications, offering data that supports transparent and responsible decision making. As previously stated, the content catalog is a time-saving feature that allows you to access sustainable building components. Autodesk Content Catalog offers architects and engineers a library of pre-designed sustainable components. On your Autodesk Construction Cloud, you can add and load Autodesk-specific families with sustainability in mind for sustainable components, such as green certified windows, low emissivity doors, and energy efficient fixtures that can be easily integrated into Revit's projects. This feature saves time and ensures that the project teams have access to the components that meet the industry's sustainable standards, reducing the time and resources required to source eco-friendly materials. By incorporating standardized, sustainable components from the content catalog into your Revit project, you can run a carbon insights analysis on the building to see what the impact will be on the environmental performance while streamlining workflows. The content catalog and carbon insight together support both individual project sustainability and the industry-wide shift towards green building practices. Navisworks, Civil 3D, InfraWorks, and Tandem for digital twins during operations and maintenance, for sustainable coordination and site design. Navisworks is Autodesk's project review software that aids in sustainable construction through enhanced project coordination and clash detection. By identifying and resolving conflicts between disciplines early on, Navisworks reduces the material waste and construction delays, supporting sustainable construction practices. Meanwhile, Civil 3D and InfraWorks facilitate sustainable site design and infrastructure planning. Civil 3D's tools for stormwater management, grading optimization, and soil conservation helps engineers design sustainable infrastructure, reducing the environmental impact of site development. InfraWorks enables urban planners to assess environmental factors such as topography and flood risk, ensuring that the infrastructure integrates harmoniously with the natural environment. These tools promote sustainable development at both the building and community levels, contributing to resilient, eco-friendly urban design. Civil 3D. Enhanced corridor transitions. Civil 3D now offers advanced controls for corridor transitions, helping architects streamline complex designs for ramps, ADA-compliant slopes, and daylighting adjustments. This feature allows smooth integration with environmental workflows, reducing rework and supporting resource-efficient roads and transportation designs. ArcGIS integration, the latest Civil 3 update, deepens its integration with Esri's ArcGIS, enabling design in a real-world context that takes sustainability factors such as watershed and vegetation impact into account. This real-time connection to environmental data is key to reducing environmental impact at the planning stages. InfraWorks, Revit family interoperability. InfraWorks has improved interoperability with Revit, allowing the use of detailed parameterized components. This facilitates cohesive workflows for sustainable infrastructure design, as data can now be shared seamlessly between InfraWorks and Revit for enhanced structural design, such as eco-friendly bridges and transport systems. Elevation measurement tool. The tool enables precise elevation measurements, essential for optimizing site design to minimize environmental impact by preventing excessive land grading or soil disruption. Navisworks, class detection and model coordination. Navisworks remains an industry leader in clash detection, especially valuable for sustainable construction by identifying potential issues early and reducing waste through error reduction. Its improved collaboration tools with BIM 360 or the Autodesk Construction Cloud also facilitate better communication across teams, allowing them to make eco-conscious decisions on material use and scheduling, which limits emissions during construction phases. And in Tandem, digital twin capabilities. Autodesk Tandem's digital twin technology allows for lifecycle tracking of materials, energy use, and waste reduction by creating a comprehensive digital asset of a building. Architects and project managers can predict and optimize for sustainability metrics throughout the building's life, enhance operational efficiency and energy conservation. These tools together foster sustainable architectural practices through data integration, lifecycle insights, and real-world environmental mapping, enabling architects to reduce a project's carbon footprint effectively. The lifecycle and workflow of a new building using the Autodesk AEC collection. The Autodesk AEC collection provides a comprehensive workflow for designing, analyzing, constructing, and maintaining buildings. The AEC collection tools can be utilized for a new building project, ensuring seamless collaboration and efficient project delivery. During your planning stage, starting with the pre-conceptual design or early design and massing with Autodesk Forma. The journey begins with Autodesk Forma, where conceptual massing models are created. This phase includes exploring building forms, testing site conditions, and evaluating initial design feasibility. The key features would be massing tools, environmental analyses, and early-stage data visualization. The outcome, conceptual massing model to guide further during the design stages. The existing condition for the site, you have the site survey and the preparation done with either AutoCAD or Civil 3D are used to prepare site surveys, drawings, and detailed layouts. The software ensures accurate representations of site dimensions, boundaries, and other critical elements. Key features, precise drafting, geo-referenced data, and compatibility with multiple file formats, especially with Revit. The outcome, the site survey data ready for integration into the project workflow. The collaboration for cloud environment, Autodesk Docs. The project transitions to Autodesk Docs, creating a central repository for storing and managing the project's data in the cloud. Key features is the file versioning, issue tracking, and real-time collaboration. Outcome, a shared model accessible to all stakeholders for a multidisciplinary work environment. The costing, the schedules, meetings, RFIs, combination of documentations, contracts, contractors, subcontractors, tendering documentation, etc. Design development stage will be done in Revit. Import your Forma pre-conceptual design into Revit with your Civil 3D site model with a geo-referenced data. Then collaborate this model. The collaborative model is then brought into Revit where the detailed architectural modeling, material assignment, and schedules are developed. Revit's BIM tools allows architects and engineers to build a robust digital twin of the proposed structure, which can then later be used with Tandem. The key features: parametric modeling, material libraries, and dynamic scheduling. Outcome: a detailed 3D model with material specifications and schedules and construction documentation. Within Revit, do a building performance analysis. Use the Autodesk Insight. Autodesk Insight integrates with Revit for advanced building performance analysis. This includes the energy efficiency, solar exposure, thermal properties, and more. The key features is real-time data visualization and optimization recommendations. The outcome: improved design decisions based on performance analytics. Then environmental analysis. Revisit Autodesk Forma. Take the refined Revit model, export it, and send it back to Autodesk Forma for further environmental analyses, including the wind simulations, daylight assessments, noise analysis, areometric analysis, solar impact studies, all the different types of analyses that are available. The key features is comprehensive environmental analysis tools, and the outcome: a validated design aligned with all your sustainability goals. The construction documentation. Returning to Revit, do the construction drawings, the documentation, and detailed plans are all developed within Revit. This phase focuses on creating the documentation required for building permits and contractor execution. Key features: view templates, annotation tools, and automated schedules. Outcome: complete construction documentation ready for local authority or municipal approval. Then building stage. Pre-construction. Collaborative construction workflows. Use the ACC Collaborate Pro. With ACC Collaborate Pro, the team ensures real-time interaction between the architects, engineers, and on-site construction teams. Key feature: cloud-hosted models, issue management, and clash detection. Outcome: seamless collaboration between office and field teams. Construct. Construction management and takeoff. Autodesk Construction Cloud Build and Takeoff. During this construction phase, Build helps manage tasks, track progress, and oversee safety compliance. Simultaneously, ACC Takeoff automates quantity estimation for better cost management. Key features: task management, RFIs, and automated takeoffs. Outcome: streamlined construction management and cost efficiency. Then operate stage. This is for the handover and operations. Autodesk Tandem. Finally, Autodesk Tandem supports the handover process by turning the digital twin into an operations-ready asset. This ensures the building's lifecycle data is maintained for facility management and maintenance of the structure. Key features: digital twins, integration and lifecycle management. The outcome: an operational building supported by comprehensive data for long-term maintenance. In summary, by leveraging the Autodesk AEC collection, professionals can create a seamless workflow from early or pre-development stage to building operations. The interconnected ecosystem ensures data continuity, collaboration, and efficient project delivery for modern architectural sustainable projects. Additional tools that are used within different industries are the other software applications that we mentioned in this webinar, such as Navisworks and Civil 3D. The workflow focuses on architectural high-rise buildings and is only an example workflow. And then conclusion of today's webinar. Autodesk offers various solutions for sustainability in design, operations, constructions, and maintenance. Autodesk's role in a sustainable future for architecture. Through a carefully crafted blend of software, AI, and data analytics, Autodesk has established itself as a leader in sustainable design and construction. The AEC collection tools from Revit and Insight to Carbon Insights and Green Building Studio empower architects, engineers, and contractors to make data-driven decisions that promote energy efficiency, resource conservation, and low environmental impact by continuously enhancing its platforms to address emerging sustainability challenges. Autodesk supports the transition towards net zero buildings, resilient infrastructure, and a greener built environment. Autodesk's commitment to sustainability extends beyond individual projects. influencing the entire industry by promoting a culture of environmental responsibility. Architects and construction professionals are now equipped to make a profound impact, leveraging Autodesk's powerful tools to design for a sustainable future. In doing so, Autodesk not only advances the architectural profession, but also contributes to a more sustainable, equitable world. If you have any questions, please do not hesitate to contact us here at Micrographics. I hope you found this webinar to be informative. If you haven't subscribed, please do so, and don't forget to like and hit that notification bell for future webinars. Thank you again, and goodbye.